Okay, if we want to find the slope of a tangent line to this given polar curve at a point, then we're going to need a way to find dy dx using what we have here, our r and theta information. So first of all, if we want dy dx, we need to see what x is in terms of r and theta, and x is always r cosine theta. But we want to replace the r with what it equals, which is 3 cosine 2 theta, and then we still have the cosine theta piece. And we know y is always r sine theta, so let's put the r in, 3 cosine 2 theta times the sine theta. So now, if we want dy dx, we're going to want dy d theta over dx d theta. So let's take y, which is right here in terms of theta, and take the derivative, and we can see that's going to involve a product rule because we've got two pieces there. So let's take first 3 cosine 2 theta times the derivative of the second. The derivative of sine theta is cos theta, plus the second, which is sine theta, times the derivative of the first, and the derivative of cosine is negative sine, and it's going to be 3 sine, but the chain rule will generate a 2, so that's going to make it a 6 sine 2 theta. Okay, so that is our derivative dy d theta. Now we need to take dx d theta, so if we look here at x, we've got another product rule. So we've got first, which is 3 cosine 2 theta times the derivative of the second. The derivative of cosine is negative sine, so I'll put sine theta there and put the negative right there. And then we've got second, which is cosine theta times the derivative of the first, and the derivative of cosine is going to be negative sine. I've got a 3 in front, and the chain rule is going to generate a 2, so that'll be 6 sine of 2 theta. Okay, now what we need to do is we need to evaluate this when theta equals pi 6, because we want to know the slope of the tangent line when theta is pi 6. So let's go ahead and put pi 6 in everywhere for theta. So we got 3 cosine 2 times pi 6 is pi thirds. And then we've got cosine of pi 6 minus 6 sine of 2 times pi 6, so that's pi thirds, times sine of pi 6, and that's all over negative 3 cosine, that's going to be pi thirds, and then sine pi 6 minus 6 sine of 2 times pi 6 is pi thirds, and cosine of pi 6. Now I just need to evaluate these, and when I evaluate trig functions I just think of the unit circle. Here's pi 6 and here's pi thirds. This is larger x, smaller y, so this one's square root 3 over 2 and 1/2, and this one is 1/2 and square root 3 over 2. So let's go ahead and plug in those pieces that we need. This is going to equal 3 cosine of pi thirds. Our pi thirds cosine's the x value, so that's going to be 1/2. Cosine of pi 6 is going to be square root 3 over 2 minus 6 sine of pi thirds. That is going to be square root 3 over 2. Sine of pi 6 is 1/2. And then over negative 3 cosine at pi thirds, that's the x value, that was 1/2. Sine of pi sixths, that's going to also be 1/2 minus 6 sine of pi thirds was square root 3 over 2, and cosine of pi 6 is another square root 3 over 2. Okay, let's simplify a little bit. Let's multiply each of those pieces. So it looks like the first one we have 3 square roots of 3 over 4 minus 6 square roots of 3 over 4 over negative 3/4 minus 18/4. All right, so one of the things we can do is we can multiply top and bottom by 4, and that's basically going to get rid of our fractions there. So we have negative 3 square roots of 3 over negative 21. And the two negatives will cancel, and we can reduce the 3 and the 21. So we're going to just get square root of 3 over 7. So that is the slope of the tangent to the curve at pi 6. If we go look at the curve pi 6 somewhere in here, that looks reasonable. It should be a positive slope somewhere in there.